Hello, we are here for more of 4-3. You've had your little review of how to multiply and divide fractions. So now we are going to apply that to rational expressions. And so our first thing is, what is a rational expression? So a rational expression is the quotient of two polynomials. So that means we're taking a polynomial on top and we're dividing it by a polynomial on the bottom. So this is an example of a rational expression. Now, we want to know how to simplify these. So you've learned that when you have a fraction like 6/4, you can look and see, okay, what factors do those two numbers have in common? So if we write 6 as 2 times 3 and 4 as 2 times 2, those 2's on the top and the bottom cancel, and we're left with 3/2. The same is true when we are using or talking about polynomials. So what we want to do first is factor these polynomials completely. So what we're going to do is we're going to first look for our GCF, which we have one in the top. We're going to take out x. We get x squared minus 5x minus 24. Then we have x in all three spots on the bottom here. So we have x squared plus x minus 72. Then we look at what's inside of our parentheses. Here we have negative 24, so 1 and 24, 2 and 12, 3 and 8, 4 and 6. The 24 is negative, our 5 is negative, so we're going to make each of these negative, and that is what they add up to. So then our top becomes x times x plus 3 times x minus 8. Now we know that we have that in factored form. So now I'm going to do my bottom. And we have a negative 72. So we have 1 and 72, 2 and 36, 3 and, oh goodness, guys, 24. 4 and 72 has a lot of factors. 4 and I'm pretty sure it's 18, 6 and 12, and then 8 and 9. 72 is negative, our x is positive, so we make all of our little numbers positive, and there's the one that's going to give us positive 1. So we have x times x minus 8 times x plus 9. Easy enough, right? So now we have these x's in common and our x minus 8 in common. So since those appear both in the top and the bottom, we can actually cancel them out. And so that means that our final equivalent expression is x plus 3 over x plus 9. So there is our simplified expression. And that's what's going to go in that box at the bottom of your page is the simplified expression. And what that means is that there's no common factors other than 1 in the numerator and denominator. So now let's look at example 2. Now I will tell you, with these examples in the video, we're going to see a lot of stuff that you're not going to you won't see this all in one problem again. But we're trying to see all of the pieces or all of the possibilities of things that could happen. So I'm going to start by factoring the top. That is a 2 expression thing. So we're going to have 2 minus x, and it's a binomial. That was the word I was looking for. A 2 number thingy. You love that. It's a binomial. So 2 plus x is a difference of squares. And then on the bottom, we just have a good old traditional trinomial. So we're going to have negative 10, 1 and 10, 2 and 5. 10 is negative, 3 is positive. So there's what we're going to put on the bottom. So we have x minus 2 and x plus 5. Now, what you'll notice is that none of these look exactly the same. But if you have something that looks similar, and I'm going to circle these two look similar. The only difference is that the 2 on top is positive and the 2 on the bottom is negative, and the x on top is negative and the x on the bottom is positive. So these are exact opposites of one another, this expression here. So that means we can take out a -1 from that 2 minus x, and we now have x minus 2 on top. And so when we write the rest of our expression, we now have this number and this number, or factor, this factor and that factor that are the same. And so they will cancel. And so our simplified version is going to be -1 to plus x over x plus 5. Now, if we go on to example 3, we are going to start multiplying them. Now, you have to recall that when we multiply fractions, we multiply our, well, first, hold on, 5/12 times 3/10. Okay, first of all, we want to look to see if we can cross cancel. So when we look at the 3 and the 12, do those have anything in common? Well, yeah, sure they do. They can both be divided by 3. So this becomes 4, and that becomes 1. And then we look at our 5 and our 10. Well, these are both divisible by 5, so the 5 becomes 1, and the 10 becomes 2. So we essentially have 1/4 times 1/2. Once we get to that point, we just multiply the tops, and we multiply the bottoms, okay? So 1 times 1 is 1, 4 times 2 is 8, and there is our product. So for this one, we're going to do the same thing. So we're going to go 2xy over z times 3x squared 4yz. So I'm going to look, do these have anything in common? Well, we have a 2 and a 4, so that can become 1 and 2. And then we also have that y and that y in common. Then we look at this direction, and this z and the 3x squared don't have anything in common. So now what we have left on top here is this x, which we're multiplying by the 3x squared, and that gives us 3x cubed. And then on the bottom, we have our z and our 2z. So that is going to give us 2z squared. And there is our final product. So now, with example 4, we're going to be multiplying a rational expression and a polynomial. You can also multiply rational expressions and rational expressions. We're going to get there. But what you always need to do first is factor before you multiply. Factor and simplify. Do you like that? Before you multiply, factor and simplify. So on the top, we're going to get x plus 2. We're going to factor and simplify the first one first. And we're going to get x squared minus 4 and x squared plus 4. Again, you probably won't see that anything to the 4th power like that again, but just in case you do, here we go. Then you should notice that this is also a difference of squares. So we're going to have x plus 2 over x plus 2, x minus 2 times x squared plus 4. Now, before we do anything else, remember when we were looking at fractions that had the same thing in the top and the bottom? We can cancel those out. So what we are left with is 1. So don't forget that this doesn't make this 0. Canceling the top does not make it 0. That's 1. X minus 2, x squared plus 4. And that's a good place to pause for this video. So we'll resume this in video 2.